Okay, so in this video, I'm just going to try to give you, go through a few things on the linear programming project. Some people have been asking for some help. I did it during a virtual class session, but some of you weren't able to join. All right, so under course handouts, videos, and notes, you'll see the directions for the linear programming project, okay? In that, you see the link at the top actually takes you to a video I created about linear programming. Okay, what you should do first, though, is to print the attached file if you have access to a printer. The attached file has notes, okay, guided notes, and I want you to watch the video and complete those notes. Okay, you'll turn this in together with the problems in my MyLab. Okay, so I give you what you need to be able to complete the notes, and then we work through an example. And then on the rest of it, you're going to go to our MyLab math course, click on the linear programming project, and work the 4 problems there. Okay. And you want to use graph paper when you're graphing the systems. You want to show your work and all that. And then I included a template for you to use for problem 4. If you don't use the template, still organize your work that way. Don't forget, I need you to show your work on those 4 problems in that MyLab math assignment, okay? So what I thought I would do to help is to go to that assignment. I did this, like I said, during one of my classes, and just kind of give you a glimpse of the 4 problems and make sure you know how to get started on those, okay? So I expect more than just this to be done. You need to be showing your work. So here's kind of what I should see, okay? So on paper, you would do what you would do to graph these lines, collect the data you need to be able to graph those lines. So what we have to do on this is we have to graph those 4 inequalities on this coordinate plane, okay? So like for x greater than or equal to 0, we graph x equals 0, okay? And if x equals 0, we're going to wind up getting a vertical line right here. So you would wind up graphing that. All right, and then we want it to also be greater than 0, so we know we're going to be to the right of that. Because x equals 0 means all your x's are 0, so that's why it turns out to be right there, up and down, right at the y-axis. So you do the same for the y. That's going to turn out to be here, and you want to shade above. And then what you would do for the 7x plus 2y less than or equal to 14, so you would graph that inequality, which means you graph the equation, okay? And so you would plot points. You'd find some ordered pairs that satisfy it. So like if I put in a 0, I get a 7. If I put in a 0 for y, x would be 2. And sometimes I'd have to show a little bit more work. Like if I put in a 1 for x, okay, that would be 7 times 1 plus 2y equals 14. So I would show that work on my paper. That would be 7. So when I subtract 7 from both sides, I'd get 2y equals 7. So y would equal 7 halves. Okay, so I do whatever it takes to graph the line. So if I graph that line, it would look like this. Solid line. And then I need to decide how to shade. So that's when I test a point, like the origin. And I plug in a 0 for x and a 0 for y, and I look for whether that makes it less than 14. And 0 is less than 14. The answer is yes. So I know I would shade towards the origin, okay? So far, I know I'm in the first quadrant and I'm below that line. So do the same for the last equation, get the 4th one on there. So it's going to look something like this. See how it should be shaded. Mine wound up being all 4 inequalities wound up giving me this set of ordered pairs, okay? Now I'm going to go back to the actual tool to make sure you know how to use the line tool and the shading tool. So let's say I'm trying to graph the 7x plus 2y is less than or equal to 14. When you click on the graph, you have the option of choosing your tools. So I'm going to pick the line tool. And when I do, I go to my graph and I start plotting the points. So I know that point, and then it was 0, 7, and see how it made a line happen. And when you're doing inequalities, you sometimes need a solid line, sometimes need a dashed line. See how I can toggle back and forth? These need to be solid since they have or equal to on them. All right, now we haven't graphed everything, but when I'm ready to do my shading, I click on the bucket tool, and that allows me to shade one side, or I can, I just want to clear the one. I'll see what happens. Okay, or I can shade the other side. You see that? And then once you get all, you wouldn't shade yet. You'd wait till you get all 4 inequalities graphed and then just shade that final region that we would have as the answer. Okay? All right, now let's move to the next problem. It kind of does another component of the linear programming questions. So what's happened here is somebody has they've already graphed the inequalities, okay? So what's happening on the second problem is somebody's already graphed all the lines, and here's where they were, right? There were 4 lines. It looks something like that. And then they found the corner points already for you, okay? Okay, so there were 4 corner points. All right, and they've already determined the expression, the rule for the objective function. And so you know the objective function. That is what I was telling you is usually going to be the profit or the cost, that type of thing. It's going to be the thing that you're looking for a maximum or a minimum of, and that's what this problem kind of goes through. So for instance, point A was the ordered pair 311. And so for that, you would plug in 3 for the X and 11 for the Y and just work that out. So that's 15 and 33. So that gives you 48. All right, you would do the same for the other points. I'm just going to do one more. So point B is 7, 5. So I'm going to plug in 7 for the X, and I'm going to plug in 5 for the Y, and I'm going to work that out. Okay, so that's going to give me 40, 50, it looks like. Okay. All right, now you do that for C, you do that for D. All right, once you do, the next question you're going to get is to find the maximum of the objective function. So you would do all 4 of them and say this turns out to be the highest. That's what you would put in for this question B. Okay, the maximum would have been 50. And then if they wanted the minimum, you would look at all 4 of these and just put in the value that turned out to be the smallest of all of those. Okay, so that question is just another component of the linear programming. All right, so let's go back and let's look at the third question. Okay, the third question has you kind of run through the whole problem, but it's not in context. Okay, so this right here, let me snip that. So on the third question, okay, what you're going to do on that, the objective function is z equaling 6x plus y. Okay, we use that later. That doesn't get graphed or anything. The constraints are what you have right here, all those inequalities. So kind of like what we did on problem number 1. This is going to be like number 1. Okay, you're just going to go in and you're going to graph all those things. It'll look something like this. Okay, all right, and then you'll go in and you'll get everything else graphed. And you would show your work on paper, do this on graph paper before you come and put it on here. You would show things like, I know it's going to be here. I know I'm going to shade up. For this one, I would then use a test point. So I would be doing a lot of things on my paper like this. You know, the ordered pairs I'm using. And then when I test a point to see which way to shade, I would show that. Okay, and knowing that it's yes, so I would be telling myself this. All that I would be doing on my scratch work before I go in here to try to graph. All right, so then we would do it for the other one. Okay, and it turns out also to be aligned. But when I do my test point on that one, 0 plus 0, the answer is no, so I shade the other way on that one. And so once I get my shaded region figured out, I identify my corner points, okay? And so on mine, I have certain corner points. So I would identify those corner points. So like one of them turned out to be 0, 6. One of them turned out to be 4, 0. And then there were a couple others. All right, what it's going to ask me to do next, or what it's asking me to do on this one, is to find the value of the objective function at each corner. So that's when I would pick up the z equaling 6x plus y. And what goes in the box on B would be all the values I would get when I plug in those corner points. So I'd plug in 0, 6, and I'd get 6. So I'm going to put 6 in the box. And then there's going to be multiple answers, and when you put them in, you just put commas in between them. You plug in 4, 0, and you get 24. Okay, so you put all of those in, and then you continue the problem, which will involve answering which is a maximum, I think. Let's go back and see what it asks for real. Okay, so find the value of the objective function at each corner of the graph region. So you put the values you find after you plug in your corner points. Then it says use those to determine the maximum value of the objective function and the values where that occurs. So you would put whatever the highest value is, once you plug in your corner points, you would put that into the box there, and then you would take the ordered pair where that happened and separate it and say that happens when x equals this number and y equals that. Okay? All right, now the fourth question is finally one in context. Okay? So here's where what you do is you go in and you think about the whole thing. So it's asking you to write an expression that represents the weekly earnings for the student. So that's going to come from, okay, I'll show you where that comes from. Come on. Okay, so let me help you a little bit with getting the setup of this first part, and then I'm going to leave the rest of it to you, okay? So for the objective function is kind of the question you're trying to answer. It says the student earns this much for tutoring and this much for being a teacher's aide. Okay, you're going to let X be the number of hours spent tutoring and Y is the number spent teaching. And it says we want the objective function to represent the student's total weekly earnings. So that just comes from that first sentence. Okay, that's going to be where the objective function comes. And in this box right here, I would just put 14 times X plus 6 times Y. Because if they tutor for 2 hours, you would multiply by 14 to get their earnings tutoring. And if they say are a teacher's aide for 5 hours, then I would put 5 there and get 30 is what they earn as a teacher's aide. And then adding those two gives me their total weekly earnings. All right, now the constraints sometimes get people because it's hard sometimes to interpret the correct inequality to use here. Okay, so let's work on that. So first off, when it says no more than 17, it means you can work 10, 11, 12, you can work 15, 16, you can even work 17. You just can't work 18. So you have to work less than or equal to 17. Okay. Now the language at least 2 hours, they must work at least 2 hours, means they can't just work 1. They have to work 2 or more. So they have to work more than, greater than or equal to 2. You would write for that one. And then the last one is back to the language no more than 8. So that's less than or equal to 8. Now let's get the variable part in here. It says to have enough time for studies, the student can't work more than 17 hours, no more than 17 hours. And see, this student is a tutor and a teacher's aide. They do a combination of jobs. So however many hours they spend tutoring together with the number of hours spent as a teacher's aide better not wind up being more than 17. So you add that that sum has to be less than or equal to 17. Now, 2 and 3 only involve tutoring if you read it. The tutoring centers require that each tutor spend at least 2 hours per week tutoring. It's all just tutoring. And tutoring, up at the very beginning, was what X represented. So this should just be X greater than or equal to 2, and this should just be X less than or equal to 8. Okay? And when you graph things that are X equals, don't forget, those turn out to be vertical lines when you graph them. Okay? If all the X's are 2, you're going to be on a vertical line. All right, so then the rest of it, I think you'll be okay with. What you do on the rest is kind of what the previous problems did. You graph the inequalities, you look for corner points, you plug in your corner points, and then you determine where the maximum occurs, and you write the given information that you need in the appropriate spot. Okay, so I hope that helps. I'm going to try to get this posted just to be an additional resource for you.